So last time we met, we were looking at line of symmetry. Line of symmetry. We discussed that one at length, and I believe people have no problem how to determine the line of symmetry. So we discussed on how to determine the line of symmetry for different figures. I mean, for different shapes. Just give me a minute. I want to show you something. Yes, members? Members? Yes. Uh-huh. Hey, this is not 16. Sorry. This is supposed to be 6. Hexagon has a line of symmetry of how many? As what?
6.
As 6, not 16. Who wrote that 16? Was me?
Yes.
Yes. Was a mistake. Sorry. Is what? Is 6, eh? So we also went ahead and look at, I gave some exercise for people have discovered that, but Bridget, whenever you are drawing, that's why I told you people to use Manila cards. To use Manila what? Cards, so that you can measure this length very well.
I don't have Manila.
Yes, even if you are using what, at least you would have measured all this distance to be equal, because it's a regular what? Hexagon. So which means all the sides must be equal. All the sides must be what? Equal. The reason why I was telling you to do that, so that you can come out with the accurate diagram. And you can see the line of what? You can see the line of symmetry clearly. Are you together?
Yes.
Yes. Then another reminder I must also give you is for a triangle. It's also for what? A triangle.
A triangle.
We have different type of triangles, members. Which type of triangle is this?
Isosceles.
This is isosceles triangle. Isosceles what? Isosceles triangle. Isosceles triangle. This is isosceles. For isosceles, it has only one line of. It has only one line of what?
Symmetry.
Only one line of symmetry. What about equilateral? What about equilateral triangle? Let's continue with our table here. So this one is going to become number 6. Number 6. Equilateral triangle. Equilateral triangle. Equilateral what? Triangle. And we said for equilateral triangle, all the 3 sides are what? All the 3 sides are equal, right? All the 3 sides are what? All the 3 sides are equal. All the 3 sides are equal. So let's have a sketch of that. And we see how the line of symmetry for equilateral triangle look like. So this side is equal to that. This side is equal to that. Okay? Okay? So the first line of symmetry, the first one will be this one. The vertical line of symmetry will be this. Okay? Are you together, members? That's the first line of symmetry. So that when you bring this one here, it will form that. Then another one, because this side, all of them are equal. So you find also this one, this one can also give us another line of symmetry here. This one can also give us another line of symmetry. This one can also give us another line of symmetry. This one here. Okay? Are you seeing that, members? Are you seeing that? Then this one, because all the sides are equal, even this one can also give us another line of symmetry. Because all the 3 sides are equal. 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 Like that. So how many line of symmetries are you seeing there?
3.
There are 3, good. So this one has 3 line of symmetry. Okay? Are we together, members? Are we together?
Yes.
Which other type of triangle do we know? Which other type of triangle do we know? Yes? Which other type of triangle do we know? Is what we call the what? The slants, okay? The slants what? Triangle. The slants what? Triangle. What is a slant triangle? All the 3 sides are not equal, okay? They are different, okay? It's just a triangle like this. Just like that. Just like that. That is a slant triangle. So for a slant triangle, it has no line of symmetry. It has no line of what? It has no line of? This one, none. Okay? Okay?
Yes.
So in other words, 0. In other words, what? 0.
0.
That is for what? Which type of triangle is that?
A slant triangle.
The slant triangle. Then equilateral has how many?
3.
Then isosceles. Then isosceles. Isosceles triangle has how many?
1.
As 1. Good. Now, like you have seen for the hexagons here, for all polygons, for all the what? For all the what? Regular polygons. The line of symmetry is equals to the number of sides. Note, write down note here. Note. All regular polygons. All regular what? Polygons as the same number or lines or line of symmetry as it what? As the same number of symmetry as it what? As the number of what? The number of sides. As the number of what? Sides. Are we together, members? Are we together? All regular polygons as the same number of line of symmetries as the what? As the number of sides. So which means if I'm talking about octagon has how many sides?
7.
Octagon. Is it not 8? Septagon, like that. So which means the line of symmetry depends on the number of what? Sides. Depends on the number of what? Sides. Are you together, members? Are you together?
Yes.
So like for kite, then again, Bridget.
Yes.
What you drew, that was not a kite, that was a rhombus. What you drew, it was not a kite, it was a rhombus. Okay? A kite like this, this for a kite. A kite look like this, Bridget. Look like this. This is a kite. This side is equals to this. This side is equals to that. The opposite faces are equal. The opposite faces are what? Are equal. So, and we discovered that it has only one line of. It has only one line of what? It has only one line of symmetry, because it's when you bring this one that it combines, but you can't bring this one like this. What about for a rhombus? Rhombus. For rhombus, all the sides are equal, not so? For a rhombus, all sides are what? All the sides are equal. All the sides are equal. All the sides are equal. So this is equals to that. This is equals to that. So how many line of symmetry does it have?
4 lines of symmetry.
The first one is it? The first one is this one, right?
Yes.
Then the second one?
The sides.
The side, the horizontal line, eh? Then the third one? The side, not so. This one,
Yes.
eh?
Yes.
This one. Then the fourth one is this one, okay? The fourth one is this one. Like that. So this one has one line. This one has how many? This one has 4?
4.
4 lines of symmetry.
Teacher, what of a heptagon? Heptagon.
Heptagon.
Yes.
Heptagon has how many sides? 7, not so?
Okay.
Yes. 7 sides, which means it has 7 lines of symmetry. That's why I said all regular polygons. All regular what? Polygons. They have the same number of the symmetry as the number of sides. The line of symmetry is equal to the number of sides. Okay? Okay. So line of symmetry is equals to the number of what? Is equals to the number of
sides.
Number of sides. So like for heptagon, we found that 6 sides. As how many line of symmetry? 7. I mean 6. Octagon has 8 sides, which means as how many line of symmetry? As 8. Are you together?
Yes.
Yes. So I believe we are together now. We have understood. Right? Is there any question on line of symmetry again? Is there any question on line of symmetry? Bridget, have you seen how you draw? Are you seeing how you draw the line of symmetry? Bridget, have you seen how you draw the line of symmetry?
Yes.
Yeah. There must be a common point. But members, why do we study that? What is the use of this line of symmetry? What is it for? This is now one of them is a design. You can use it for designing different patterns. Like if you have parties there at home. If you have parties at what? At home. You can make some like a birthday party. You don't need to go and buy this thing from the supermarket. You can design it on your own. That's why I was telling you to use manila cards. So that you learn how to design this thing. You can design using the line of symmetry. You can come out with different figures, with different designs. Are you together, members? Are we together?
Yeah.
Because now when you draw like this one, take for example a rhombus. If you draw the line of symmetry, you can cut to come out with a flower. Are you aware of that? You can come out with a good flower. If you have used a good manila, if you have used a very good manila paper, like if you want, depends on the color you want. Yeah, like if you use a red one, which is very attractive, you draw the line of symmetry. The first thing is to do, you draw a line of what? Symmetry. Then you start cutting. You start what? Cutting. You find out you will come out with a very good figure, which can help you design your birthday party rather than just buying things from a supermarket. Okay? Are you together, members? Are we together?
Yes.
Yes.
So the task I'm giving, that's your project, the project I'm giving, okay? Using the line of symmetry. Using the line of what?
Symmetry.
Cut for different figure, whether you want for a triangle, depending on your choice. Whether you want for the hexagon, for any polygon, for any shape, or you want for a kite, okay? Okay?
Yes.
Cut for me different shapes. Don't say, teacher, which shape should we do? I want you to be creative. So just cut any shape. Cut maybe if it's a rhombus, cut a rhombus using line of symmetry. Then design any figure from it. Design any figure from a rhombus. If it's a kite, design any figure from a rhombus. Any design. Are you together? If it's a triangle, design any shape from there, any design from there. Are you together? Are we together, members?
Yes.
Yes. Adokoraj? Adokoraj?
Yes.
Adokoraj, I saw your work. It was nice. Only that you did not draw it well. Okay? This time you take your time and draw it well. Take your time and draw it well. Okay? That manila paper was good and the color was also good. So using line of symmetry, design a good shape there. You can even put in a sitting room. After designing, you can put in a sitting room. Members, I give you one, I show you one. For me, what I can do, if I was the one, I was going to draw rhombus, series of them on a manila paper. On a manila what?
Paper.
On a manila paper. Then I cut them. After cutting them, you find that it will give you a very good shape. It will give you a very good what? Shape. That you can even put like you can put on a wall. You can put on your wall in the sitting room. It will make the room very attractive and nice. So that's one thing. I wish we were in school. If you are in school, it will become very easy. We are going to use manila and then we design. But if you come back, we shall still do the same. Okay? Okay?
Yes.
But now is my request, because we're at home, request your parent to buy for you some of these manila papers or some of the colored papers you need for you to design this shape. Are you going to do it?
Yes.
Thank you. Thank you. Thank you. Thank you. Okay, let's proceed. Subheading, members. Subheading. Reflection in a plane mirror. Subheading. Reflection in a plane mirror. Reflection in a plane mirror. The other time when I get people to do research on a plane mirrors, people did their research and it was good. Members, we all have dressing mirrors at home, not so? We all have dressing mirrors from home. Who doesn't have a dressing mirror at home? Members, do you have dressing mirror at home? Whether small or big? You have,
Yes.
If you have a small one, please, then you carry it and have it there with you. You pick it and let it be there with you as the teaching is. We are going to use it. You pick it and use it there. If you have a big one, you can also carry it if it can be carried. Okay?
Yes.
I've given you 1 minute for that. 1 minute. Get one plane mirror from there. Get one, please. Get one. I'm waiting. Members, have you got it?
Yes.
Okay. Members?
Yes.
You have the dressing mirror there with you. That dressing mirror you have, that dressing mirror you what? You have is a what? Is an example of a plane. Is an example of a plane what?
Plane mirror.
Is the example of a plane mirror. Why are we saying a plane? Because it is like this. Whether it's circular or what, vertical, it is like this, right? Not so? Not so? Then one side is what? Do you see one side is coated? One side is what? One side is coated. Members, one side is what? One side is coated. Now this is the reflecting surface. This is what we call a reflecting what? Surface. Then this side is a what? Is the coated? Is the coated what? Surface. Is the coated what? Surface. Now when you stand in front of a plane mirror, you find that there is image form. You see yourself through the mirror, not so? Hmm?
Yes.
So when you are standing, we call you an object. Okay? We call you an what?
An object.
But your image, I mean, what you see behind the mirror, you see what you see in the mirror is your image. Is your what? Is your image. And there's something very interesting with the plane mirror. Let me show you here. There's something very interesting there. If this is a plane mirror, right? This is a plane what? This is a plane mirror. This is a plane mirror. And for you are standing here, let me assume that is resting on a surface like that. Is resting on a surface like that. I think these members, you are standing here. Let me assume, who is this? Who is standing here? This is the object. This is the what? The object. So you find that there's going to be a ray of light. You find that your image, your what? Your image will be formed. Let me use a dotted line there. Let me use a dotted line there. Will be like that. So let me draw it and you see, I will draw the ray diagram for that. Like this. Then you can also have another ray here. This is physics now. This is not mathematics. We find that the object distance will be equal to the image what? Distance. So this distance must be equal to this distance here. It will be equal. It will be what? It will be equal. So you find that the image will be formed here also. The image will be formed there. So you find that we shall have that. Like 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 that. Okay? Like that. Like that. You find that this one will be reflected. Will be what? Will be what? Reflected like that. Even this one will be reflected like this. So this is reflected. But you find that your image is behind. The image is what? This is the mirror.
Behind.
The image is behind. And if this is the object distance, the object what? The object what? Distance is equals to the image what? The image distance from the what? From the what? From the mirror. So if you stand 5 meters away from, if assuming here you are 5 meters, even your image will also be from what? 5 what?
5 meters.
5 meters. If you are tall, even your image will be what?
Oh.
If you are short, even you appear to be what?
Short.
Short. You have seen that. You try to focus. If you try to see your head. If you have a big head, even your image will be what? Big. If you have a small head, even your what will be a small? Small. Right, together?
Yes. Yes.
That's another fact. That's another fact. Then the second one, the image, the objects, the image size. The image what? The image what? Size is equals to the object what?
Size.
The object size. If you have a big head, even your image will be big. If you have a small head, even your image will be small. Are you together, members? Are we together?
Yes.
Those are the two things I want you to pick from the concept of a plane mirror. Okay? Okay? And all this concept we have seen is coming from a line of symmetry. It's coming from a line of what? From a line of symmetry. Take for example, for as human being, how many line of symmetry do we have for human being? How many? Eh? One. Not so? Because I'm not good in fine art. Let me try. Okay? Let me what?
Right.
Let me try. Whose face is this? Let me see. This is somebody's.
Yours.
This is somebody's face. Is mine?
Yes.
Your nose is there. Something like that. Something like that. Eh? Then your mouth is here. Okay? Okay? So if I'm to cut your face laterally like this, okay? Like that. I sing that. Members, I sing that?
Yes.
You find that I can bring this one to form this side because I've divided your nose, I've divided your eyes, I've divided your mouth, I've divided your chin. So if I'm to fold it there, you find it will form one. So you find that our face has only one line of what? Only one line of symmetry. That's why you are able to see yourself through the mirror very well because we have only one line of symmetry. Okay?
Yes.
Teacher.
Yes?
Teacher.
Yes.
In case we have one and one, what will happen?
Which means it will not, because the line of symmetry determines the number of images to be formed. Are you together?
Yes.
Are you together? Like if I'm to put like what? Which figure should I put? Like a rhombus. Like a what? A rhombus. Members, like a what? If I'm to see a rhombus, you will see how many lines on the screen. You will see also how many lines? You will see what?
4.
4. Why? Because a rhombus has how many lines of symmetry, members? Has how many? Has 4. Okay? Are you together?
Yes.
But because for
Yes.
human being, we have only one line of symmetry. That's why you see yourself as one. You see only one thing on the screen. Okay? Okay? I did mean that we have 2 lines of symmetry, which means we'll be seeing how many faces we'll be seeing on the screen?
2.
We'll be seeing 2. Yes. So that's what we'll be seeing. So for us human being, we have only one line of symmetry. That's why we're able to see ourselves through the dressing mirror. That's why we are able to see ourselves through the dressing what? Mirror. Point driven home. Point driven home. Members, have you understood that?
Yes.
Yes. Okay, let's now, that's explanation. Let's go to notes. Let's write our notes. Let's put our notes down because we have understood now. So we are saying a reflection is a transformation. A reflection is a transformation such that any two corresponding points in the object and the image are both the same distance from the fixed line. From the fixed what? Line. So we are saying that line of symmetry is a reflectional. Line of symmetry, not line of symmetry. Line of what? Line of what? Symmetry is reflectional. Is reflectional because it give the image. To give the image of the object. They give the image of the what? of the object from the other side. From the other what? Side. From a fixed what? From a fixed what? Line. From a fixed what, members? From a fixed what? Line or a point. From a fixed line or a point. From a fixed line or a point. From a fixed line or a point. Then what's a plane mirror? A plane mirror is a normal flat mirror that gives an accurate reflection. So a plane mirror is a normal flat surface. Just put surface, sorry. It's a normal flat surface or a mirror that is shiny. That is what? Shiny and give an accurate reflection. Give an accurate reflection of an object. Of an what? Object. Are we together, members?
Yes.
Good. Let me know people are taking notes. Don't just sit there as if you are watching TV, please. Be taking notes. Okay? Even this one I've drawn here, I expect someone to have drawn it also down there so that you understand what we are talking about. So we started from here. This one we are giving general perspective. Now here we are putting it in notes. We are putting in writing. So we're saying a plane mirror is a normal flat surface or a mirror that give and shiny and give an accurate what? Reflection of an what? Object. And that reflection is what we call what, members? That reflection is what we call what? That reflection give us the what? Give us the what? The image. That reflection give us the what? The image. So we are saying so can we draw these, members? Can we draw this? Let's draw this. Consider a Cartesian plane. Consider a Cartesian what? Plane. So if I talk of a Cartesian plane, I'm meaning X and Y axis, X and Y plane. X and Y what? Plane. Consider X and Y plane. So this is what we have. This is what we have. So this is our Y axis. This is our X axis. Like that. Like that. Like that. So let me say this is a point here. There's also another point here. There's also another point there. And there's also another point here. There's another point here. So let's say this is it. This is it. 1, 0. This is negative 1, 0, sorry. Then this one is 1, 0. Then this is 0, negative 1. Then this is what? 0, positive 1. Are we together, members? Are we together? Are we together, members?
Yes.
All right. So we want to understand something from there. We want to understand something from there. So we have less than a minute. We have less than a minute. We are saying the figure. So let's say this is our object. Remember, this is our what? This is our what? Object. This is our object, which means the image. If this is the mirror, if this is the mirror now, and the object is here, where will the image be? Members, where will the image be? This is our mirror. Where will the image be? The image will be here, no, sir? The image will be what? Here. Why? Because the distance from here is 1. Even here from here is also what? 1. If this is our mirror, the object is here, the image